Hello everyone, welcome to Maans Chandigarh IS Academy. Myself Neeraj Nachiketa. As I have started with the topic of science and technology, so continuing with the topic here, space science and technology, we have discussed last time launch vehicle technology, and in that context I have discussed about India's launch vehicle program, and there we have discussed about PSLV, Polar Satellite Launch Vehicle, GSLV, Geosynchronous Satellite Launch Vehicle, and in that context I have said GSLV Mark II and Mark III, what we call as a LVM3, Launch Vehicle Mark III. We have also discussed about SSLV, Small Satellite Launch Vehicle. So now I am coming to a very important thing which you are aware, and I have mentioned in the session also there, what is called RLV, Reusable Launch Vehicle. Reusable Launch Vehicle. Reusable launch vehicle. And I have mentioned last time that space shuttle of NASA, which goes and comes back, but now it has been retired. That is Atlantis, Endeavour, Discovery, Columbia, Challenger. And I have mentioned that Columbia, Challenger have met with accidents. So now only three are left: Atlantis, Discovery, and Endeavour, which have been placed into museums. And I have also mentioned that NASA is now returning back to the moon, taking humans to the moon. There's a mission called Artemis mission. So in that case, New Orion spacecraft, a new type of vehicle being created. I have also mentioned that now private entities have come into space field. Now Elon Musk company SpaceX, Falcon 9 Heavy, it has developed. At the same time, there are other contenders who are developing the launch vehicle technology. Now RLV, if you look at from the government agencies, that is American Space Agency NASA, Russia's Space Agency Roscosmos, and third is the Chinese Aeronautical Sciences, CAS. These are three countries which possess this technology of RLV. Now India is developing RLV, right? The purpose of developing RLV is twofold. One is that human space flight, taking human astronaut to the space, bring them safely back to the earth. And second thing what comes, that is reducing the cost of launch of satellites and launch and spacecrafts. Imagine if you have a RLV which can go to the space with the communication satellites, remote sensing satellite, launch the satellite and come back. Again, we can get ready for the next launch. So our cost of launching satellites will be reduced by 1/10. Right? That is what the cost advantage comes. So RLV, if you look at here, the first thing is that it uses a system. There are two components. That if you look at technologically, the way this technology has been developed, there are two components. The first thing is that you have a winged aircraft. There's a winged aircraft, like the jet plane, like here kind of a jet plane. Right? So this is a winged aircraft. Now this is the aircraft which come back. Right? This is the aircraft which comes back. It returns back to the earth. Right? After going to the space, it come back. Now at the same time, what is very important here? This winged aircraft is taken to the outer space with the help of boosters. There are boosters there. There are boosters there, which basically carries their boosters are there. These boosters carry the spacecraft to the outer space. Right? So what I am drawing here, these are heavy boosters are there. And this is a winged aircraft. So the boosters take it to the space, they get removed and fall to the earth, which can be recovered and used again. And the winged aircraft which goes to International Space Station or wherever the work is there, and they return back to the atmosphere, and then land on the runway. So what is very important here, the first component is that boosters, and second component is a winged aircraft. India's technology is also based on the same concept here, right? Will be based on the same concept here. So boosters, that this takes winged aircraft with human astronauts or whatever spacecraft we want to ferry to the outer space. To the outer space. And the winged aircraft here, this houses right here astronauts that return back and land on the runway, that return back to Earth, right, from the outer space. So this is the basically a technology. What is something called here? 2 stages to orbit. We say here 2 stages to orbit launch vehicle here. It goes and come back. It goes to the space and come back there. Right. So if I draw a diagram here to make you understand it more better, so you can understand like this. This is where with the booster, right? With the booster, you have a aircraft here. Right. So what happens here as it goes there? So the boosters get removed. Right. This is a booster which is separated. And this booster, right, falls to the ocean there. And the winged aircraft, this winged aircraft remains, it goes to this outer space. And the same winged aircraft has a re-entry. What is called re-entry? It re-enters to the atmosphere and then land on the runway. And land on the runway. So this is the general profile, right? This is the general profile what you find in terms of a RLB technology. So when you say RLB technology, this is what comes into that, right? So it is a very advanced technology which comes into that. And recently, India did the testing of a very important kind of a spacecraft here. So we had a Pushpak. Pushpak has been named given to the winged aircraft, which ISRO has developed there, and it has a 3 times landing experiment. We carried out a landing experiments, right? So we had a LEX 01, LEX 02, LEX 03. These 3 landing experiment, and this was successfully carried out. Successfully carried out in Chitradurga, that is a place in Karnataka, where the landing of this kind of experimental aircraft from the atmosphere, it was done on the runway here, Chitradurga in Karnataka. So you could expect a question in the exam, right? You could get the question in the examination on this aspect there, right? This can be a question which can be asked in the exam there. So this is where it was in the news there, right? Where this small aircraft which we have developed, later on this will become the real RLV of India. So last time it was dropped. It was dropped with the help of Chinook, with the help of the Chinook helicopter. and then it landed on the runway in Chitradurga in Karnataka there. So that means all the trials have been done, all the important components have been tested, right? They have been tested there, and now the thing is that to develop the real one and can send it. Although Gaganyaan mission, India is going to use LBM-3 rocket. So for Gaganyaan, what we are going to carry out, that is India's first human space flight. So there is a use of GSLV Mark 3, that is LBM-3. This LBM-3 will be used, which is nothing but a modified form of GSLV Mark 3. Right, this is nothing but the modified form of a part of. So here, what we see here is that in the case of LBM-3, I have discussed last time that it has two heavy boosters. That it has two heavy booster. Right, and then you have the liquid, right, liquid core engine, right, liquid core engine. And then followed by cryogenic, L110, S200, S200, and then this is a cryogenic engine. And here what we are going to have on the top part of it in Gaganyaan mission, we'll have a kind of a crew module. This will be a crew module with the service module. This is going to be crew module. This is going to be the crew module where astronauts will be part of the system there. See, that's what, initially the first time when we are doing, we are going to use the our traditional rocket, what is called GSLV Mk3 Mark 3 modified from LBM-3. That will be used, right, to take the Indian astronauts to the outer space and drop this crew module, which will return back to the Earth with the help of parachute system. What is something called re-entry? This module will re-enter. Very similar to what Yuri Gagarin did, who is the first man to go to the space. That was the thing there. But later on, we will not use this rocket. We are going to use what I have discussed just now, RLV, where we will have a winged aircraft, where astronaut will go and come back. Let's say I have said that we are going to build Bharti Antariksh Station in coming future. So Bharti Antariksh Station, BAS, by 2035-36, that there we require number of manned mission to take all the module and dock it to build the station. So, but that is only possible when we have RLV. Although the first time we are trying with the LBM-3 rocket to take the crew module to the space, low Earth orbit, and bring it back. They will drop this module to the ocean with the help of parachute system. But later on, we'll have a proper space shuttle, just same as NASA, Roscosmos, CAS. That will have a proper space shuttle with a winged aircraft where it will go, and that aircraft will come and land on the runway. That is our plan. So here, this part is there. So we are going to use that. And here, a crew module with the Indian astronauts. Right, will be launched in low Earth orbit. In low Earth orbit, that is 300 kilometers, around 300 kilometers orbit around the Earth. And then this crew module, after staying there, the crew module will re-enter Earth's atmosphere and drop to the ocean. Drop to ocean with the help of parachute system. With the help of parachute system. with the help of parachute system. So this is what we have planned for our initially manned mission using the Gaganyaan there, right? It is very similar to the Axiom 4 mission. Recently, Group Captain Subhashu Shukla, one of the astronaut of the Gaganyaan mission, he went to International Space Station with the help of Axiom 4 mission. And you've seen that crew module with carrying 4 astronauts came back to the Earth. The same type of thing will be done in the case of Gaganyaan. And this type of endeavor which was done with the Mr. Subhashu Shukla is just a kind of a training and getting that kind of things as what India is planning to do it. That's what the things comes into that, right? So it becomes very, very important to understand here. But later on, we will use for in future. In future, we will be going for. So in future, after in future, right? India is going to use RLV for human mission, for human space mission. After successful Gaganyaan mission, right? And this will pave. This is going to pave. This will pave, right? Pave, right? For building India's space station. Because we require those kind of human space flight, right? So that will be in the future. So even this can be asked in the examination. You'll be getting the question in the examination about all these factors there, all these things. Question can be asked in the examination, right? So this is where the Pushpak landing experiment becomes very, very critical in this context there. And the significance, that the importance of having RLV, right? Even the part of the question will be like this: what is RLV, right? And discuss India's progress in RLV. And then the next part will be that what is the significance of this RLV for India, and then what are the challenges and problems which RLV program face. Long type question there. Or you may have the what is RLV, discuss development RLV for India with its benefits and challenges. And you have to write in 200 words, 250 words. So all those kind of you will be asked to write here. So if you look at here, the importance here, right? Significance for India's space program of reusable launch vehicle. So we can put across following points here. What is first point here? Point number 1 is that will help in human space flights. We can carry the astronauts to the space, right? That is possible. Manned mission, what is called here called manned mission. Right. Second thing could be what here? It will reduce cost of here launch of satellites, like say Earth observes remote satellites, or let's say when we talk about communication satellites, right? By 1/10. Then the 1/10 of the cost, 1/10, then the launch by conventional ELVs, the expendable launch vehicles, like PSLV and GSLV. We reduce down the cost here. And then comes here what? Third thing is that we can provide space service to other foreign countries, other countries for taking their astronauts, and we can earn revenue there by using this their astronauts and bringing them back to the earth safely, back to the earth. Space service to other countries for taking their astronauts and bringing them back to the earth safely, and we can earn revenue here, earning foreign exchange revenue. That could be the part of it. That means because our RLV and the service given through RLV for taking astronauts to the space and bringing them back will be much cheaper compared to other countries, even to the private companies like SpaceX and all this. So that cost benefit India's RLV provide in terms of space market. So that means what does that mean here? That means it is going to increase our share in the space market. It is going to increase our share in the space market. India's share in space market. Today, we are just having 2% of the share of the global space market. But this is going to increase that share what we are holding right now. It is said that $350 billion, that is what target we can achieve by coming 10 years. That is space market. We can earn revenue from there. We can have a earning of revenues through this kind of a program there. So that's what it becomes very, very significant. It becomes very, very significant for India's progress in space technology, And now we are inviting the private players into space field in India. That is again going to boost our domestic level kind of thing there. So this is what we have. We are moving into that one. Now what I'm coming here, the last part of the launch vehicle technology, what we need to be aware of that. Now recently the cabinet has approved NGLV, next generation launch vehicle, So now we are going for even more advanced rocket there, Now we are going for more advanced rocket technology there with the NGLV, Next generation, or you can say new generation launch vehicle. Now this is going to be a game changer for India's space program. Now what is here? What is the plan here? That which cabinet has given the approval and budget has been allocated, has approved to develop, and this will be even more advanced than LVM3. Develop the most advanced space rocket, most advanced rocket by ISRO. Now, what is the thing here? It will be having a payload capacity. If you look at presently, LVM3 can go up to 4 ton. That is limitation, because if there is any satellite, suppose communication satellite, which is heavier than 4,000 kilogram, then we have to take the service of France to launch this satellite there. So here, that what becomes a very important here. It will go up to here. If you look at, it will go almost 10 ton capacity, capable of launching 10 tons or you can say 10,000 kilogram, right? 1 ton equals 1,000 kilogram. Payload, that what is payload? Payload is a spacecraft or satellite which the rocket will carry, or maybe crew module or something kind of module there. Payload to geosynchronous GTO, what is called geosynchronous transfer orbit, right? Geosynchronous transfer orbit, GTO, for communication satellite, right? And it can go up to, let's say, when you look at lower orbit, it can go up to 3 times more than that. And what is a very important thing here? That is it will be a 2.5 times more heavier than the present here. Right? Heavier than the present LBM3, what we say GSLV Mark 3. That means almost around 3 times bigger than the present heaviest rocket what India has built, what is called Fat Boy, LBM3 and GSLV Mark 3, which we are going to use in the case of Gaganyaan mission. Before we have used in Chandrayaan 2 mission, Chandrayaan 3 mission, and then even for heavier communication satellite we have used that. So it will be bigger than that one. So which will be again powered by cryogenic engine, then liquid hydrogen and liquid oxygen. But now we are looking for other alternative fuel for cryogenic engine, right? So that is what we are developing that. So what I want to say that the way India has progressed over the last now 75 years and the way we are going with more and more advanced technology, that will be another milestone for India's space program, the part of the development there, right? Now I'll discuss another thing about a launch vehicle technology that is called scramjet. Let's go to the scramjet technology. I have mentioned once in the classroom, but again I am now explaining here scramjet, and is also a part of our launch vehicle program development there. So that is called supersonic combustion ramjet. What is called SC ramjet, supersonic ramjet, what is called scramjet. This is the name here. Now, when it's come to ramjet or scramjet here, what is here? It is a air breathing. It's basically air breathing propulsion system. As compared to normal ramjet engine, is an engine there, double system or engine. Compared to normal ramjet engine, which we use in the case of fighter jet or missiles, it is more advanced there. Now, what happens in this case here? If you look at here, in terms of its design here, that look at in terms of design here. So this is the this is the kind of engine design. So what happens here? The air enters, right? Air enters with a supersonic speed. What do you mean by supersonic? More than the speed of the sound, right? It uses air. That means it does not use oxidizer. Normal rocket, when we talk, it use oxidizer. But here, air enters this nozzle. That is a supersonic speed. Like the speed of the sound in air, 332 meter per second. What we refer to as 1 Mach. So here, the speed of the air entering the this engine, that is there in a range of 2 to 3 Mach. See, up to 5 Mach, that is a supersonic speed. Now what happens? The air which enters here, it is compressed, and you have a fuel here. This is a fuel. So fuel is burnt This pressure air, fuel will be burnt, right? This is a combustion engine. Here's the combustion engine, just like car or any kind of engine. We have a combustion chamber where we burn with the air. Air supplies the oxygen and the fuel is burnt. So here the fuel will be burnt, right? Now when it burns, so air is flowing like this. Air is it will generate a exhaust, high speed exhaust. Right, here it will come the exhaust. Gases will come out, that is ejected out of the nozzle. So when the burning happens inside and when it ejects with a high speed, very, very high speed, that is what called thrust. It will provide a forward propulsion. It provides a forward propulsion or what we call thrust. It provides the forward propulsion or thrust because the gases are coming in this direction. So this entire system will move in the forward direction. You know that action reaction. Third law of Newton's third law of motion. To every action there is equal and opposite reaction. Equal in magnitude but opposite in direction. So the air which enters, burn it, comes out with a very, very high velocity. So this is it's coming out. Action. So what is reaction? Opposite. Reaction will be opposite. So here when it moves there, when it comes out, so I'm trying to explain there. So here when it goes there, so here propulsion, that is in hypersonic speed. It moves with a hypersonic speed. What is hypersonic speed? More than 5 Mach. What is 1 Mach? Speed of sound in air, 332 meter per second. But when it's a hypersonic, that is more than 5 Mach. With that it moves. So it will move like this. Air will get inside, burn it, exhaust gas. Again it will give the thrust this way. Are you able to understand? This is the engine. So air, supersonic speed, burns, gas, thrust. So it gives the force this way. So air is getting supersonic, burns, exhaust, but this will move with hypersonic speed. So this is what the scramjet engine comes into that. So does not use a oxidizer. It burns the fuel with the oxygen coming from air. So this is mostly suitable for lower atmosphere, missiles, fighter jets. There we use. But in space technology, in the rocket technology, in launch vehicle technology, we can use same technology when the rocket is lifting off from the launch pad. So initially it is in the lower atmosphere. Once it crosses the lower atmosphere, then there is no air. So after sometimes the initial phase, after launch, there this scramjet can be very, very beneficial because we don't have to use oxidizer. It will reduce our cost, right? And also the size or weight of the rocket. That's what the scramjet technology plays a very, very important role here. So what is the next thing here? The next thing what comes here? It uses oxygen from atmospheric air. From atmospheric air to burn the propellant. What is something called fuel propellant, or what we call as a fuel, right? To generate hypersonic speed. What I explained with the diagram there. To generate a hypersonic speed of the vehicle, right? So again, if we look at the application part, if we look at the applications part, So first application what comes, that is missile technology. Hypersonic missiles. Then fighter jets, fighter crafts or fighter jets. Generally there where it is used there. But again now you know that same technology can be very, very important for India as a part of development in the space technology. So even we can use as a rocket or launch vehicle. Later, technology. Right. Now when you look at here in space launch vehicle or rocket, right? Space launch vehicle. There, space launch vehicle or in the rocket. What is very important thing here? Can be used during the first phase after the liftoff, because that time air is there. After the liftoff, first phases we can use that after the liftoff in the launch vehicle rocket technology. Now this is going to have a benefit. What is here? We reduce the cost. Reduction in cost of using the oxidizer. Generally, what happens there? Normal rocket, space rocket or launch vehicle, right? So there, to burn 1 ton of a fuel, we require at least 4 ton of oxidizer. So the cost of manufacturing oxidizer, that will come down. Right? Reduction in the cost. And what is second here? Second thing is that, which is very, very important, which you all have to keep in mind, that is in terms of here reduction in the overall weight of the rocket. Weight of the launch vehicle. So if the weight of the launch vehicle or rocket is reduced, so what will happen there? We will be able to carry more weight payload into the space. What can be the payload? Satellite or spacecraft. That can be heavier carried if overall weight of the rocket can be reduced. So that can be done with the scramjet engine. So reduction in the weight of the launch vehicle. So higher payload can be carried out. That can be possible there. Right? Higher payload carrying capacity will be there. So that benefits we can get in terms of the launch vehicle technology. Right? And that can be a benefit in the case of a launch vehicle technology. Right? So cost of the using oxidizer, manufacturing cost and all this, and again keeping it somewhere, using it in the space rocket, reduction in the weight of the launch vehicle. And if the weight we can manage it, then we can increase the payload capacity of the launch there. So let's say you get a question of the scramjet in the class, in the exam. So this is how you have to explain that. And ISRO has successfully tested scramjet technology. Now we have a technology. So the same technology can be used by DRDO, Defense Research Development Organization, in terms of military craft and fighter jet and missiles there, more advanced missiles. And we can also use in space technology, that is ISRO, that here during the liftoff time, scramjet engine. Another scramjet engine can be in RLV also, reusable launch vehicle, because when the winged aircraft will return back, so there the propulsion can be once it reaches the atmosphere, just like fighter jet, it can use a scramjet engine to propel in the atmosphere and land on the runway. That was possible. So not only normal rocket it can be used to take it up in the space, but also the RLV, reusable launch vehicle, that winged aircraft, once it has a re-entry. So that winged aircraft propulsion system, once it enters the atmosphere, just similar to fighter jet, can use scramjet and land on the runway. So even it has a utility for RLV application also, reusable launch vehicle application as well. So all those things in the applications, benefits you can write in the exam. Right? Are you able to understand here? So not only you can, let's the question comes, what is RLV? How RLV differs from other technology? Right? Or let's the question comes, what is scramjet? How is scramjet different from ramjet? You will explain with mechanism everything, but which I have discussed here, everything in this case. And at the same time, you'll also write with applications. What are the applications of scramjet technology? Right? What are the benefits of using scramjet in a space program? So let's say you are writing there, you will get marks there. Clear? So whatever I have explained here, they becomes a very good points for answer writing there, where you can write the answer there, right? So this becomes very, very important from coming exam point of view. All right. So I have covered, right, in the previous session and this session, launch vehicle part of it. So in our next session, we'll study about satellite technology and the applications of different types of satellites with important development from India's perspective. And then we will go to Chandrayaan, Mangalyaan, Aditya L1, Nisar and all those areas there. Till then, keep learning and be connected with Maans Chandigarh IAS Academy, and we'll meet again. Thank you.